We are to the end. Wait, let me just turn this over a sec. We're to the end of the second review sheets. Yay. Alright, let me just make sure one more time. Yeah, we're down to 46 through 51. Alright, fill in the letter of each graph next to the correct quadratic function which created it. Alright, there is a typo. Oh, class, I forgot to mention on that last video, letter B was changed on your worksheet. I should have changed it in class. Your worksheet says a different question. You should have got that corrected in class. We also have a correction on this one on your worksheet. The C graph was in the wrong place. Hopefully I've got you to correct that as well. Okay, let's take a look. First thing I'm going to do before I do anything is I'm going to find the vertex of each one. This is 0, 0. That's my H and that's my K. Actually, let's do it this way. Let's write 0, 0. And then on the bottom of the graph, let's write H equals 0, K equals 0. Let's take a look at the next one. This is also 0, 0. So H equals 0, K equals 0. Looks like equation or graph C is also the vertex is 0, 0. That means H equals 0, K equals 0. Here we got to change. The vertex here is at 2, 0. That means H equals 2, K equals 0. The vertex on graph E is at 0 on the x-axis, 3 on the y-axis. So 0, 3. That means H is equal to 0, K is equal to 3. And in the last graph, looks like we have an H and K. H is positive 1. K is 1, 2, 3, 4, 5, and negative 5. And that means H is equal to 1 and K is equal to negative 5. Let's write that a little bit neater. Negative 5. Okay, let's start off with the ones where the vertex is not at 0. So letter D, H is 2, K is 0. Let's look for an equation where H is showing up in the equation as 2. Here's the only one. Right here, H is 2. Oops, H is not 0. H is 2, and notice there's no 0 here. It'd be plus 0. That means K is equal to 0. That means this one must be D. 49 must be D. Here we've got H of 0 and H is 0 and K is 3. Let's take a look. In this equation, K is equal to 3. And I can see there is no H term, class. If you look at this, this is the same as negative 1/2 times x plus 0 squared. So in this case, H also is 0, or H is 0. That's going to match graph E. Take a look at F. We've got an H of 1 and a K of negative 5. Not sure why I put this parenthesis here. Let's get rid of it. Let's take a look at our equations. Here's the only one, class, right here for number 50. We've got an H value equal to positive 1 and a K value equal to negative 5. So 50 must be F. So we're done with the D, E, and F. Take a look at these. I cannot use H and K to figure out A, B, and C because they're all the same. We're going to have to use A. Look at this equation. This equation, you see the parabola is compressed. That means the absolute value of A is going to be small. So that means absolute value of A is going to be between 0 and 1. This one is stretched. That means the absolute value of A is going to be greater than 1. And this one looks pretty normal. I'm guessing A is equal to 1 on that one. Let's take a look. Oh, not 1. Whoops. We better fix that. That's negative 1. A is negative 1 because the graph is upside down. We only have one negative A, so cool. That means 48 has to be C. We're down to A and B. Well, stretched means A is greater than 1. That looks like 46. That's going to be your stretched one, which is B. and that leaves these 47. Well, 1/4. The absolute value of A is 1/4. That's between 0 and 1. That means that is a compressed graph. I lost my pointer here for a sec. Hang on. That's a compressed graph, and that must be A. So there is how I matched up the parabolas with the equations.